Greetings, folks, and welcome to the Electromaker podcast. And we have a very special podcast for you today. We have an interview with Zach Supalla, who is the CEO of Particle, a company that has been creating hardware and software and everything in between for IoT for the past decade. They are in the process of launching the Particle Tachyon, which is a 5G capable single board computer, which can do all kinds of nice AI things on board as well, which are, of course, words that we are getting very used to hearing a lot of things doing. But what makes this one particularly special is that it's one of the first that leverages the fact that Qualcomm, the people who make the Snapdragon chips that go in every kind of mobile phone and tablet, have pushed to get mainline Linux support, and this is a full Linux single-board computer, but with the amazing hardware that powers most of our modern smart devices. However, there's a lot more to it than that, and Zach takes us through all of that in this interview. In fact, the podcast listeners this time get a slightly longer and better experience than the regular show. The way I'm going to do this one is the regular YouTube show has the interview with Zach at the beginning, and then it also has some other stuff talking about the Blues LoRaWAN Starter kit, which is another amazing thing in and of itself, and I get quite enthusiastic about Blues, as I always do. They're one of my favorite groups of people making stuff that's easy to use out there right now. However, at the end of this show, I will also add the second half of the interview I did with Zach, so you can hear the full affair, because we ended up talking for another further 20 to 25 minutes. But I will drop in at the end of the normal show, so if you want to nip out at that stage and have a normal Electromaker experience, you can, and you can always come back and listen to the other half of the interview at another time. Before we do get into the show, a quick reminder that we support ourselves at Electromaker. We have a store at electromaker.io/shop, and that is how we make our revenue. We do not put any adverts on our podcast, and we do not monetize our YouTube videos. But if you head to electromaker.io/shop and buy something from us, whether it's a gift for someone else or something you need for your work or something you've always wanted to get your hands on but never really thought you had a reason to, impulse buys are legitimate purchases. Also, if you want to give this podcast a rating, that would very much help it with the general algorithm-driven world that we live in. And with all that said, let's get on with this week's show. We're going to start this week's show by talking about the Particle Tachyon and going straight into the Zach Supalla interview. I wanted to very quickly preface it just by saying the Tachyon is a 5G single-board computer. It runs Android hardware under the hood, so you have an octa-core Qualcomm Cryo chip, which is the same kind of thing you would find in a smartphone or a tablet, but Qualcomm have really been working to get upstream Linux support, and Particle have met them halfway to really make this a full-on Linux experience, but on hardware that you wouldn't normally expect. It has 5G out of the box, as you might imagine. It has an AI accelerator thanks to the same things that fit inside your phone. It has a certain amount of TOPS of AI stuff. And as you can see from this GIF, you have a Raspberry Pi hat attachment, camera attachment, a battery attachment, and everything else can be attached via a USB-C hub. Other than that, the only other thing you should know if you are not at all familiar with Particle, Zach does go through it to an extent in the interview, but they started around 10 years ago, and they have been making hardware and software and cloud solutions as one ever since, improving it over the years. I have a Particle Photon board, which was an IoT connected board, and you could say it's in the same vein as something like an ESP32 or something. It's a board with a microcontroller on it and connectivity. But where Particle have always excelled is in their cloud side of things. It started off with just a cloud browser and an API, and it slowly turned into an entire IoT service. As much as I found out that Zach is actually the person who I was thinking of who hates the term IoT, as do I. The Internet of Things is way too vague. But Particle has spent the last 10 years really perfecting this cloud from hardware right up to telemetry and over-the-air updates as a service thing for millions and millions of users. They have government contracts in the US. And I think that's all we really need to know running into this interview. So without any further ado, I'm going to pass you over to me and Zach talking yesterday. We had a quick interview about the Tachyon and talked about a few other things as well. So, folks, I am joined by Zach Supalla. He is the CEO of Particle. Do I have that right? You are the CEO, right?
Yep, that's right.
Lovely, yep. And is here to talk about, well, various things. But let's begin where we left off on the last Electromaker show, which was we looked at the Kickstarter for the Particle Tachyon, a 5G-enabled single-board computer that runs Linux, but has much of the same guts, as it were, as a modern smartphone or tablet. So, Zach, Particle has been around for quite some time. I mentioned to you before the call started, I've got an original photon sitting around somewhere from back in the day when I played with it, but a lot has happened since then. So how do you get from Particle beginning to putting out a quite unique single board computer?
Yeah, absolutely. So Particle's been around for about 10 years, and our business has always been some version of saying, you want to build IoT stuff, we can make that easier. Now, IoT stuff is inherently a very, very messy and broad thing, because IoT is not an industry. It's 750 industries that all got like lumped together. And within that, there's like massive, big categories. So that's it's more complicated than that. The history of the business has been in microcontrollers, which we sort of think of as like a subset of IoT, right? If you're building an internet connected thing, what that means is you're connecting something to the internet that isn't a PC or a smartphone. And there's a lot of different subcategories. Some of those are like sensors and controls. And if it's a sensor or control based system, then you're probably thinking microcontrollers, real-time operating systems. And so Particle has been in the business of making it easy to make connected microcontroller-based products. And that is used in methane emissions monitoring in oil and gas. It's used in hot tubs. It's used in air conditioners. It's used in, we track lobster boats for the state of Maine, like a surprisingly high variety of things. And our business is selling our platform to companies who are doing that at scale. But the way people find out about us, begin to use us, is development kits. And so we started with the Spark Core back in 2013, Kickstarter campaign for a Wi-Fi development kit. And then we've sort of been growing and expanding what we do ever since. The Spark Core was a STM32F103. So that was a processor that had 10 kilobytes of RAM, a whopping 128 kilobytes of flash, I want to say. And so we began, and what at the time was like incredibly constrained systems, right? We had to figure out how we're doing like encrypted communications and all this stuff that didn't fit into that little tiny processor. And so then we're on our 4th generation of microcontroller based products now, so that the world's changed. So now it's like, 200 megahertz Cortex M33s with like 4 megabytes of RAM. And it is amazing when you start with 10 kilobytes that feels like infinite resources. And there's a point where you start to hit the ceiling of microcontrollers, where you say, once you hit some point, you really should be flipping over into microprocessors, into like the lower end of that system. And so we've been thinking this for a while. Like, we're going to come up on the ceiling and we're going to start to look at ways we could support people with like EdML and video and audio and the things that are always a little more difficult to do in microcontrollers, and also writing code in other programming languages and robotics and drones and so on and so forth. And so we came up to the ceiling of microcontrollers and we said, now's the time. But we also decided we don't want to just make another Raspberry Pi, right? Raspberry Pi has done a great job of building an incredible ecosystem around single board computers. Where we see opportunity is in taking higher end technologies that have more processing power, more capabilities, and really combining that for things like robotics and computer vision and things that require kind of like heavier processors and bigger workloads. And so we work closely with folks at Qualcomm and realize there's a big opportunity to basically take like Snapdragon tech, which is the stuff that's in a smartphone these days, and use that to create a 5G connected single board computer that's very powerful, has a DSP for accelerated AI and ML models. And so that's Tachyon. It's a smartphone in the form of a Raspberry Pi. Basically, it's I like to say it's a 5G AI IoT SBC. That's my infinite acronym of what this product is.
Excellent. Yeah. And one of the things that I think will be a bit of a breath of fresh air to a lot of folks, because there's been, as you say, there's very little point making another Raspberry Pi these days, as that kind of board has been done beautifully by Raspberry Pi and done in similar ways but different by a plethora of different companies who have come up with very different fruit pie. You know what I mean?
Right.
And of course, there are some working, moving towards RISC-V and all that kind of stuff. What I found particularly exciting is that there are, of course, Android development kits out there, but they will cost you a pretty penny, which are using similar kind of tech. And there are, of course, single board computers that will run Android, but this is very much the opposite way around, because one one of the first things I thought before I really knew anything about Tachyon, I just saw that it was, Snapdragon and Qualcomm. I thought, does that mean I'm going to have to know how to develop things specifically for that platform? But you've got upstream. I mean, the basic kind of stock operating system for it is desktop Ubuntu 24.2 or something like that, isn't it? It's actually a full upstream Linux.
Yep, that's right. Yeah. We get to benefit. We're benefiting from the fact that Qualcomm, who has historically done, they've done what they need to do on like complying with the Linux GPL thing license, and they sort of distribute the Linuxes that they create, but they've never upstreamed before. And so they have started to make a push into making their products more accessible and friendly for developers, which is great because we can piggyback off of that, where they're now upstreaming Linux support. Not something we could have done. The fact that that's the case means it's now possible to build a really great high quality Linux experience around these products, where previously it really was sort of Android or bust. You technically could do Linux or like a Windows 11 kind of a thing, but you were not going to have a good experience doing that. And so the bits and pieces are there. And I think in a lot of ways, IoT is taking bits and pieces of technology that were probably designed for other purposes and then reusing them in a way that makes it possible to build new categories of products. That's sort of how I think about the market. And this is a bunch of pieces that were designed for smartphones that have been sufficiently repackaged and reoriented into something that could in principle be used for IoT, but there's still a lot of warts and hair on the bits and pieces. And so that's where we come in, is like taking all this stuff and assembling it into a really great product experience that works out of the box, very seamless, really well designed for prototyping and building hobbyist projects, but also designed to deploy product at scale with over-the-air software updates and security and all the things that you would require if you're not just thinking about one single Tachyon that you're going to put somewhere, but a fleet of them that are going to go do something out in the world.
Absolutely, yeah. And I think this leads us quite nicely actually onto the other side of what Particle do, because I talked about this in our recent show, and I'll when I edit this, I'll throw an image of the Tachyon up on the screen so I can show people this. From a hardware perspective, we are looking at something which is your kind of credit card sized single board computer, and it has the ubiquitous 40-pin hat. It has a couple of camera connectors, and everything else can be achieved via is it 2 USB-C ports, which can do everything from DisplayPort to audio, all of that kind of stuff.
Yep, that's right.
So from a hardware perspective, it's fairly well set to do anything another single board computer would do. But for a long time now, Particle has been offering an online system, browser-based system for fleet management, over-the-air updates, a whole plethora of things, which now is something I think people are very used to. There's a lot of people offering that service, but Particle have been offering it for really quite a long time. That came quite early in the Particle story, didn't it?
That's right. Yeah. It's expanded a lot in terms of what it does. So if we go back to like the delivery of Spark Core in 2014, that product was, I've got one somewhere. Where do I have one? I like this one because this is the white PCB, and like no one should ever, if anybody ever thinks, I should make a white PCB, don't make a white PCB. You're going to regret it. But this came with basically a web IDE, which is sort of a web version of Arduino, and an API. And so you could basically send in messages remotely to it, and you could send code to it. And that was kind of it, right? That has expanded dramatically over 10 years. We now articulate it online as we've got like 29 different subcomponents of the platform, which, each one of which is a rabbit hole that we could spend an hour on. But what we realized is that the scope, the depth and breadth of the tech stack for an IoT product are both a lot, right? So you end up needing to like both become a really deep expert in how cellular networking actually works. Not at the level that you think it does when you're using an iPhone or an Android where it's abstracted by the operating system, but like actually under the hood, how cellular networks work. There's a lot of stuff there. At one, you have to go that level of depth, but you also have to do that across embedded systems across communication protocols, encryption at every different layer of the stack, web services. It's a ton of stuff to build. And so the scope of our platform just keeps getting bigger and bigger because our goal has been to do it all, right? What we want to say to somebody is, look, the whole tech stack, it's just there. It just works out of the box. And we're 10 years in. I think we finally got there like last year where I could reasonably say to somebody, this is the entire tech stack that you need to create an IoT product, except for the application. The front end, it's very much like our customers build the thing that their users touch, and we just do all the infrastructure behind the scenes. So that's how we describe ourselves: edge to cloud infrastructure. The scope of what we do is broader than anybody else because we've been building it out for 10 years, and a lot of aspects of our platform are very hardened by having been in market for that long, right? So like over-the-air software updates, probably the most important individual feature of what we do. We're really good at like reliably and securely delivering software updates to a microcontroller. We do 12 million updates a month across thousands of different types of applications. And so that's been going on for 10 years. So as you can imagine, that system's pretty reliable and robust now. So you can trust it because it's been out for such a long time and has been beaten up in every possible way that anybody could try to break this thing. So
yeah, for sure. Yeah. And as you mentioned at the very start of this interview, some of these systems that require robustness are doing things like monitoring oil fields and doing actual real, quite serious work out there in the world. So it's one of those things where you're not putting together a service and hoping it stays together. You really have to actually make sure that all of the pipes are absolutely well connected without any leaks, for want of a better metaphor.
If you are deploying a methane sensor into the Permian Basin in Texas, which is about as far from anywhere else as you could be, and it breaks and you have to send somebody out, you have to send out a truck to go fix something, that sucks.
Yeah, that's a costly issue.
and those are the kinds of customers that use Particle. And so a lot of people start with Particle with the thing on their desk, right? Like if you have a thing on your desk and it gets borked, right? You just like press the reset button, you're fine. But we want it to be that you're doing the same thing when you're working on your desk that you'll do when you deploy it into a place that you will never be able to go a second time. And so we have to make it that level of secure, scalable, reliable from the first moment so that there's never like a transition path you're going through from that first prototype into large scale production.
For sure, yeah. And of course, I mean, for the engineers listening, this is all things that will be incredibly kind of important to hear because from an engineering point of view, things need to be trusted when you're going to scale. And as you say, one of the ideas behind the Tachyon is that this isn't something you'll necessarily will have one of in your business. You'll be able to deploy many of these to do many different things. And again, from an engineer's perspective, you do have Ubuntu as your main software, but there is also the option of complete rolling your own using Yocto Linux, as it says on the Kickstarter page. But jumping to the other end of the spectrum just for a moment, I think one of the things about this board that will be very interesting is that it's one of the first complete packages that will run in a sort of familiar way to hobbyists, but that is offering a lot of new things. So from someone like my perspective, for example, I'm a self-taught engineer. I've been fumbling with microcontrollers for the best part of 15 years in the hope that I'll make them do something, and occasionally I do. But if I was to get my hands on a Tachyon and wanted to kind of do my own, basically teach myself IoT from the ground up. How does that work for someone who maybe isn't in enterprise, who maybe doesn't want to put a huge amount of money into using an online platform? Because presumably there's some level of being able to use this, use the service and be able to even maybe use some level of 5G connectivity without having to pay a massive amount of fee to begin with. Is that right?
Yeah, absolutely. I mean, I think it's important that we, when we think about prototype to production, this is something we think about a lot, right? What you need in production and what you need in prototype are similar but different, right? In prototyping, what you're looking for is affordability, accessibility, ease of use, basically developer productivity, right? Yeah. So like I think like I have a job to do. I'm trying to build a thing that does a thing. And I want to be able to do that quickly and have as few barriers in my way. And I also probably have some tools and systems that I'm familiar with. And so there are some cases where like when you build something abstracted, if it's not abstracted in the way that the user expects it to be abstracted, the work that you did to try to make something easier can make it harder, right? Because you're like, well, I'm expecting to write in Python and this system requires that I write it in JavaScript or something like that, right? That kind of thing can can kill developer productivity, even if it's comes from the right place. So that's the lens we look at prototyping. And then we look at production and we think, what do you need? You need scalability, security, reliability, sort of like the fundamentals of enterprise services. Auditability, right? Like you need to know that like, oh, somebody pushed a software update. Who pushed the software update to that thing, right? These are things that like companies care about that individuals do not care about. And so we have to do both of those things, right? We have to have it be secure, scalable, reliable, auditable, and also, accessible, affordable, easy to use, high productivity, right? And we have to do all of that always, because a great way to screw up a large scale deployment is to force a transition that means all the good work that you did early on gets dropped, and like the implementation is wrong, and that means that the system isn't actually reliable, secure, whatever, right? So that's the approach that we take. And so what that means for an individual person using this as a for a hobby project is platform's free for first 100 devices. We include free telemetry over the cellular network. So if you're doing like it has a SIM card in there. If you just want to use the SIM card for like remotely triggering a script or getting basic like metrics out of it, like CPU utilization and stuff like that, that's free. Like we're not going to charge for that. And then if you want a gigabyte scale plan, so you can actually send information, like, real stuff over the cellular network, that's a 2 gig plan for $6.99 a month. So, trying to make it as affordable as we can for folks who are building it for whatever application they're building on. And then you go to scale, and then we're going to charge for the cloud service and things like that. But I think that if you don't have an intent to scale, look, the reality is we use this stuff to generate business for ourselves. So like we want to make people love our product and then use it. And if you're doing it for early development, you get to take advantage of that, right? Like if you don't have any aspiration to grow, don't worry about it. That's fine. Like we love to have as many people building whatever they want on this thing. We want to democratize these technologies and make it so that anybody can use them. And we're excited about whatever people are building on it, regardless of whether it's something that has intent to scale. And you know what? A lot of our best customers, they scaled, but they didn't necessarily have that intent out of the gate, right? A lot of great products start as hobby projects that somebody realizes is maybe worth doing something about and building a business around.
Yeah, for sure. Yeah. And I think that's a great attitude to have, because at the end of the day, people who, learn to love to use tools and use those tools well, occasionally make very wonderful things. And if they've had the opportunity to get to know their tools, then they're going to stick with those tools. I think it's a very good attitude to have. Yeah.
And importantly, I think it's as important that we not force anybody to use those tools, right? So like we have a agent on the device that provides connectivity back to the cloud service. You want to turn it off, you can uninstall it. We're running Ubuntu because we want to create a really great out-of-box experience, and we think Ubuntu is a really good like default, but a lot of people have their own preferred Linux, or they might want to run Android or Windows 11 on it. It does support those. You want to do one of those, you can wipe it and put whatever you want on there. And so we're not going to force anybody to use the systems the way that we intend for them to use. We hope that you'll try it, and we hope that you'll like it. And if you don't, we'll make it better. But we're not going to force anybody to do things in the Particle way if that's not their match.
Absolutely, yeah. Well, one of the things I always find very fascinating when anything like this comes out is I wonder what people will end up using the Tachyon for, which is not its intended market whatsoever, just because of the fact that, like we mentioned at the very start of the interview, it's a quite unique setup in terms of its hardware. And having a stable Ubuntu on top of that hardware, I think, will be something that a lot of hobby hackers would find interesting, even with no aspirations of actually taking it out in the field and turning it into a cellular IoT device.
It's definitely something we've learned from the microcontroller world, where if we go back to when we launched cellular, which we did in 2015, we were already doing Wi-Fi connected products. So we had a sense for like what kinds of things people were building. And we built cellular because we knew that there were a bunch of things that you might want to do that are outside of the home or an office. So like, okay, if you're doing, if you're doing a vehicle, right, like you need a cellular connection because it's going to be out in the world. So we thought this is about mobile and remote. And then in practice, you see what people do. And yes, that's true. There are a lot of mobile and remote applications as a big part of what people use our cellular stuff for. But also, then you find stuff that's like in a factory that is connected to the cellular network, and it's a fixed asset, doesn't move. And you say, well, why is that cellular connected? Well, you learn that turns out, any factory environment, there's some IT guy who is responsible for figuring out what goes on his network. And
not on my network.
guaranteed,
Yeah.
he looks at like IoT things and he says, nope. And now you might say, well, but some IoT devices are secure. Particle powered IoT devices are secure. If we knows that it's powered by particle, then he trusts it. No, this person does not trust anybody because he or she, they have been, they have trusted things in the past and they regret it and they've been burned. And so like they will not let IoT devices on their network. So a lot of things end up then going to the cellular network and saying, you know what, we need connectivity. We'll just use cellular. And those are things we learn. We don't know that stuff before we launch these products. And Tachyon's it's gonna give us a lot of new ideas, and we're going to discover things about what people are building. And we're already starting to see that now, just in the first couple of weeks. Like it'll be used for things that we didn't intend for it to be used for. And that's my favorite part of this whole thing.
For sure. Yeah. And as I mentioned early on in this interview, the Kickstarter is well underway, and at the time of recording this interview, things have gone quite well with it. I think you've jumped a good $240,000 over the original target, but there is still a few days left on the Kickstarter campaign, and so of course people can get involved and get the pre-orders in. And am I right with my memory of thinking that the rough given date for delivery is around about January?
Yes, that's right. So first, like the early bird orders will go out in January, and then February for the remainder. So this stuff will all be shipping out early next year.
Absolutely. All right. Well, as I mentioned on the previous show, this is the first time in a while that a single board computer has really got me kind of quite excited. I'm certainly excited to get my hands on one and have a little play with it. But is there anything, any last bits you'd like to add about the Tachyon before we move on?
You know, I think the big thing I threw out there is a little bit of a call it like a call for innovation. Like we really want to know what people want to do with this thing that's kind of outside the boundaries. And so if you've got something you want to build and it is like wildly crazy, we would love to hear from you and know what you want to work on and figure out what we can do to make that easier. Because our job fundamentally is about taking hard problems and making them easier. That's a lot of infrastructure in this context, right? A lot of things that are necessary to get this stuff working, we want to eliminate, so you can just go build whatever great product you're going to build. But what you need from us is different depending on what kind of thing you're trying to build. So if you're trying to build, a crazy robot that is going to do all sorts of autonomous things, or you're trying to, build some new application for, some new thing with cameras that no one's ever thought of before, come talk to us. Obviously back the campaign, but tell us what you're working on and tell us what we can do to make your life easier.
Fantastic. Fantastic. And those links, of course, as to how you can get in touch with Particle will be in the description of this show video or wherever this ends up getting posted. Zach, thank you so much for giving me some of your time today.
Cool. Likewise. Thanks, Ian.
So that was Zach, and I hope you enjoyed watching that interview as much as I enjoyed giving it. I really got on well with Zach, and we will definitely be talking to him again in the future in one way or another. We actually talked for another further 20 minutes or so after we finished that little condensed interview, and I'll release that separately at some point in some way, maybe on the podcast or something like that. As I mentioned in the video, all of the links that are relevant will be under this video. The link to the ongoing Kickstarter, where they've already absolutely smashed their goal. There are still some of the early bird versions of it left. You can still see the super early bird Tachyon for $149. There are still 130 of those if you're interested in getting in on the ground floor and getting a cheaper version of it. And you will also be the first to get your hands on it if you do. If you'd like to find out more about Particle in general, I've linked to their website in the description of this video too. And further down on this Kickstarter page, just one extra recommendation. There is a video from their chief technical officer, basically just going through what sensor data is like, sensor data collection and management is like using the Tachyon, which is of course very important for something which is a cellular IoT device. That's mainly what they do. They have sensor data, and that data is put up into the cloud, and then various things can happen based on that data. And of course, various things can happen back on the site with the workings from the cloud. We've talked about this many times before, being able to change hardware from the cloud and being able to change the cloud from the hardware. It's sort of what Particle do, top to bottom. So yeah, as I said before, I hope you enjoyed that interview. It took up a fair chunk of this week's show, but it's not all of it, because we do still have a very exciting thing to talk about, which is our product of the week. Just a quick reminder that if you would like to support the Electromaker Show, the best way that you can do so is by visiting electromaker.io/shop and seeing if anything from the thousands upon thousands of products we have, from everyone from Raspberry Pi to Arduino to Nordic Semiconductor to everything from Adafruit and Sparkfun and Pimoroni and much more, if any of that appeals to you, that money directly financially supports what we do. We don't run any adverts on YouTube, we don't run any sponsorships on our podcast, we entirely fund ourselves via our own shop. That said, if you are here on YouTube, it would mean a lot if you make sure you have subscribed to this channel, make sure that you have clicked like on this video, if you like it, of course, and leave a comment on the video saying what you like about it, what you don't like about it, or more importantly, what are you working on right now? I love hearing what people are trying to get done. I have been trying to build a synthesizer for literally years now, and I have bits and pieces all over in different spots where I've tried different things, so many different code bases just trying to make digital synthesis. I'm really interested to hear what's the projects that you're in process of doing, and of course, once they're finished, stick them on the Electromaker Project Hub, and then I'll talk about them in the show. Anyway, let's get on with said show. We're going to talk now about our product of the week, and that is the LoRaWAN Starter Kit from Blues. Now, I'm going to keep it relatively brief because I've said so many times the same thing about Blues, and the same thing is true here as far as I can understand. Blues' workflow is the easiest way to get into pretty much any kind of connectivity for your hardware project. Whether it's cellular IoT or Wi-Fi, and now LoRaWAN or even satellite, you have note cards that can talk in various different ways across various different networks, and you talk to them all the same way, and that is via JSON commands. The Blues LoRaWAN Starter Kit, however, comes with a hub and various different LoRaWAN nodes that allow you to place them throughout an entire space and have them communicate with each other, and only need the hub as the single point of reference to connect to the wider internet or whatever you wish to do with that data, which obviously has various advantages in various different places where perhaps you can't or do not want cellular IoT connectivity, or there's a million and one reasons why you want different kinds of radios. And from my perspective, the fact that Blues are making a LoRaWAN kit would be enough for me to consider getting one anyway because of my experience of getting up and running with the Blues Note Card Starter Kit. That was the cleanest and smoothest cellular IoT experience I've ever had. But anyway, this is a product of the week, so you don't need to take my word for it. We, of course, have our in-house engineer and gadget guru, Robin Mitchell, to take you through everything you need to know. So, as always, I will leave it to Robin to go through all of the technical details of what the Blues Starter Kit for LoRaWAN can do and some of the use cases you might have for it. One of the things that I was interested in, having been so amazed by Blues' documentation for getting started, would be if I was to have one of these right now and I wanted to set up a LoRaWAN network in my house, how easy would it be and how flexible is it? Because it's all well and good having these LoRaWAN nodes, but if you're already using LoRaWAN and you have your own gateway, for example, does Blues force you to use their own gateway? Well, the answer is, of course, no. And in fact, just having a quick look at the quick start guide, connecting to a LoRaWAN gateway, as always, they have these wonderful charts showing you exactly how everything works. If you do use the Blues gateway, it removes one level of complexity for you because they manage absolutely everything. This is working on the Things stack from the Things network, one of many LoRaWAN networks that you can choose. And so if you have the note card LoRa, which is API compatible with the cellular IoT note card they have and the Wi-Fi IoT, it's a JSON API. I say that over and over again. If you can format JSON with your microcontroller or your single board computer, and there are many libraries that help you do it, you can use any note card in any situation. It connects to the Blues gateway and then goes to the Things stack, the Blues app server, and the Blues Note Hub, as we've talked about in the past. This is Blues's what's the word I'm looking for? Oh, it's hot. I'm losing words. It's too hot. This is Blues's secure end-to-end way of talking between your hardware and the cloud. They do all of the encryption stuff for you, and then they can put it onto your cloud, as it says, whether that's AWS, Google Drive, or a myriad of other things. However, if you already have a LoRaWAN gateway, you can spin up your own thing. All you need to do is get the LoRaWAN gateway working, set up your network server, have your own packet broker, and then you end up in the Blues app server and in the Note Hub and to the cloud. So there's a couple of extra steps, but of course, if you already have your own LoRaWAN hub, I would imagine you'd be quite familiar with sorting that kind of thing out. The Blues hub can connect via Ethernet or Wi-Fi, but I'm not going to go into too much more detail again because this is why Robin has made our wonderful product of the week. I was just curious to see how easy it would be to get started. And this, by the way, is one of my favorite things. Ignore the unsupported browser thing. I use a special version of Brave for doing the show. My experience of using this on various different devices has been out of the box plug and play. This is a terminal inside the browser. You can plug in your note card and actually get started with it without having any SDK stuff on your side at all. In fact, you could theoretically do all of the programming of any note card you ever use just through the browser if you know what you want it to do, because again, it's JSON commands. If you want to say, wake up and send a message from this sensor every 15 minutes, and that's all you ever wanted to do, then you never need to install an SDK, which is wild and wonderful. Anyhow, I highly recommend checking out the video from Robin here. It goes through everything you need to know about the LoRaWAN kit, and of course the article as well goes through it all in text as well. And if you'd like to find out more about it, you can head to this blog here. It'll be linked in the description of this video. The purchase link is the first one right at the top here, and from the purchase link you can click the Getting Started guide, which can take you to all the same documentation I have just been speaking so highly of. And there are various other useful links throughout every Product of the Week video as well if you're interested in finding out more. So yes, I'm going to pretty much leave it there. I have had nothing but a positive experience with Blues. If you are someone who is interested in getting into LoRaWAN, would you be tempted by this Blues kit? And perhaps more importantly, if you are someone who's already been working with the LoRaWAN network for quite some time, taking a look at what Blues is doing, what are your opinions on it? Because I always find that from my perspective, it's very easy for me to get very excited about things that are easy to use because I have so little time. And if I want to get something up and running, as much as I love getting in the weeds, getting as close to the bare metal as possible as a hobbyist, if I really wanted to achieve something, barrier to entry is important. But I'm very interested in hearing your thoughts on the matter. And as this is a product of the week, yes, we will be giving away a Blues LoRaWAN Starter kit. The competitions here at Electromaker are incredibly simple. All you need to do to enter them is be subscribed to this YouTube channel, the Electromaker YouTube channel, and leave a comment on this video saying what you would build if you did win a Blues LoRaWAN Starter kit. And also leave the hashtag BluesLoRa, Blues L-O-R-A, no spaces, which will allow us to see all the competition entries and filter out any repeat entries. The winners will be chosen at random and announced on the next Electromaker Show, so you have plenty of time in order to put those in, as there probably will not be a show coming out next week as I am going away, although there may be. But yes, either next week or the week after, we will be announcing the winner of that competition. For now, get entering, let me know what you'd make with it. Good luck. So that is where the YouTube show for this week ends, and I will at this point say thank you for listening to those of you that only want to listen to this length of show. Although, as you can probably see, if you can see the timeline of the podcast in your app, there is some time still to go, and that is because I will immediately follow this interview and play you out with the second half of the interview I had with Zach. But for those of you that will be leaving us here, thank you so much for the continued support that you're showing us. Thank you to everyone that goes to electromaker.io/shop and supports us financially by buying things from us, and to all of you who are out there listening to us week on week, thank you very much indeed. I will chat to you very soon and hand you back now to me and Zach. So right at the end there, I lost your camera, but it's not actually too much of a problem because that part where you're actually talking about getting in contact, I'll probably overlay the Kickstarter page, and I'll overlay the Particle website as well so folks can see it. But yeah, right now your camera kind of pinged out and then it came back at a different angle.
Yeah, so this is of course like I have strong opinions on cameras, and so I use an Opal, which is like one of these newfangled, high-end webcams. Except inevitably, it's buggy as hell because it's a startup that's making it, and so it's just occasionally it just stops working. So I just rebooted it, and it popped back.
Yeah, no, that's totally fine. I live in the land where, because I make a weekly YouTube show, I have a DSLR camera going into a capture card. Capture cards are the most wonderful, beautiful things in the world 99% of the time, and then it's 1% pure rage and screaming.
Yep. I've definitely had that experience in the prior iteration of this. So I'm you just keep swapping it out for something else, hoping it'll be better, and it's always the same.
Yeah. That's very much a metaphor for having a life in technology.
Yes, exactly. Never quite works.
So I don't know what your timing looks like right now, but if you wanted to, we could do a few more minutes just so you can go over maybe in a little more detail, sort of that original idea where Particle came from, and maybe just a few sort of milestones through the years of kind of where Particle, as you say, a lot has changed in that kind of 10-year period of time. And I think Particle is a name that a lot of people are somewhat familiar with, but unless they've had some kind of hands-on experience with it, might not know as much about. And so the idea being that the first chunk we just did, I'll let into the show as is, and then this second part can be a bit more freeform, and it can either go out just as a podcast or maybe just as a standalone video, or maybe it'll get lost in the annals of Electromaker, and who knows. But
let's do it. I've got till the bottom of the hour, so I'm ready to go.
Oh, lovely stuff. Okay. Well, that actually works quite well for me as well. So, I mean, I suppose you already talked briefly in the section before about it's starting out as something quite small. But I know from a different interview that the original Stephen idea for Particle, before it was probably even called Particle, was the need for a Wi-Fi or some kind of connected device in order to give a visual cue for someone who was not able to hear. Is that correct, or do I have that backwards?
No, that's right. So yeah, if we go back in time, right? So I started the business in 2012, although we didn't ship the first product until 2014. So we sort of think of it as this is our 10th year. But if we think of where we were in 2012, this is sort of the beginning of the current era of IoT, which is to say, we started calling it IoT at that time. This has existed as M2M or like telemetry and telematics. Like there have been many words to describe what we call IoT these days.
Is it just, I don't want to interrupt you, but is it you, is it from an interview that you also agree that IoT is just a terrible name for something, right? Is that you?
It's the worst. It's the worst.
Yes, you. Really, okay. Like, I think that too. Oh man.
Is that all we've got, guys? We couldn't do better than this. Like what I love is when people try something different, and we have had many. The first 5 years of the business, we probably didn't have IoT on the website because I refused to use the term. We talked about connected devices. There was a period where like Cisco was trying to call it Internet of Everything. Right now I see a lot of like AIoT, which God, I hate that even more. It's amazing. You can't take two acronyms that both have an I in them and stick them together when the I means something different in artificial intelligence as it does in internet. You can't do that. Anyway, sorry. I'll put that internet troll away. The beginning of this phase of the industry, I sort of think of Nest as being like the launching pad for modern IoT. And that's because I think that it was a very visible moment where like the guy who created the iPod, Tony Fadell, left to start join an early stage thermostat company basically. And it's like, what? Why it doesn't make any sense. And the story that he told was that thermostats were an unloved product that basically hadn't been touched by technology over a 50-year period where we created the personal computer, the smartphone, the internet, Wi-Fi networks, cellular networks, right? Like all of these major technology innovations had happened over this period and none of them had touched this product. So if you then just take the product and you reimagine it using modern technology, you end up with the Nest Learning Thermostat. And that was an idea that was very inspiring to a lot of entrepreneurs. So you had this like wave of hardware startups that popped up in like 2012 to 2015. A lot of people were like, that idea makes sense in basically every product category, right? You can take anything and ask the same question of it. Like, how would you do it better now with modern technologies? And that's IoT, right? And that's why it's not really an industry. It's like it's a mindset and it's an approach and it's a basket of technologies, right? That apply to anything, right? So when we started, it was originally called Spark. My idea was, my dad is deaf. I wanted to make his lights flash when my mom sent a text message. And this was essentially the fact that like, prior to that, we've always had a flasher in my house, where it was sort of plugged into the phone jack, right? Where like if a phone call came in, which in his case was a call on his like teletype, his T2i, then the light would flash, right? And so then he started using his cell phone, not for voice calls, but for text messaging. And he would like take the phone out of his pocket and leave it somewhere, and my mom could never get a hold of him. And so that was the original, like, I was like, lights should have an API, right? I should be able to. That's not a great product because the deaf community is very small. So it's hard to build a business around that market. That's really an app, right? Like there should be a notifications app for your lights, but in order for that to be true, your lights would have to have an API. And so
Yeah.
I got really excited about this idea that like the physical world around us should have an API and that you should be able to interact with that API. The first product for that we launched on Kickstarter and it crashed and burned, and so we never made it. But
Mhm.
the in building that product, we learned firsthand about the challenges of the tech stack and the infrastructure necessary to create it. And I'd worked previously with manufacturers, and so I knew that like typical manufacturer isn't full of like dozens of engineers who are like sitting around and waiting for a new project to do. Like they're very and technically resource constrained. And so I'm thinking like, how is any company that makes widgets gonna do this? We can make that easier, and that's what turned into the Spark Core, and then eventually Particle as it is today.
Yeah, which makes sense actually, because like I mentioned just before, it's probably one of the reasons why you've been actually doing the sort of online browser-based stuff for so long, because by necessity, you're not talking about coming up with a piece of hardware that you have to download a massive SDK to program in a million different ways. You're talking about something which is designed to work with an API. It's weird. In a parallel universe, I could almost imagine Particle being a company that didn't go into its own hardware and just came up with a tech stack for working with other supported hardware. You know what I mean?
Yeah, and in some ways it's funny. We think of most of the value that we do is in the software platform. We have debated, as you can imagine. I mean, probably every year we talk about like, should we just make it something that you can use with any hardware device? And it's likely at some point we will, right? Like, I actually don't think it's not like that's off the table or like a fundamental belief around ours. It's just that it never quite feels like has never quite felt like the right moment. But a big part of that is I really think that this is one of the most challenging things to articulate sometimes. A lot of the value that we deliver is in the interstitial layer, meaning like it's not actually in any one of those blocks that I would put up in a block diagram and say like, this is what we do. It's in the interconnections between these things that make it kind of just work, right? And so the value of having hardware isn't that our hardware is all that special. Sometimes we do, like, I mean, I think Tachyon's a great single board computer and like there's really cool stuff we did here, but I also think like other people could do this, right? There's the special sauce is in all the work that we do to make the services that we provide integrate really well with the devices that we target. And that is both often hard to articulate and hard to execute on. And the fact that it's hard to execute on is why it's useful, because it's hard for people to figure out on their own and we can just do it and it works. And the practical experience then is, I think we do a better job, not actually like describing to people why they should use Particle, but by just saying like, look, don't worry about it, get one, you'll figure it out. And then like people use it and they're like, well, that was easy. And it kind of just works. And they go try to do it another way. And it's like, that didn't work. I'm like, why did that work and that not work? I don't know. Particle magic, right? And like, that's cool, right? Like that's really where, that's what we want to make true, that it just kind of works. And then that is something that our customers think goes valuable and they want to keep using. And that's sort of how the business has grown.
Absolutely. And I think anyone who has tried even to come up with a very simple kind of connected IoT device, for want of a better phrase, and try to do it completely by themselves, will understand the value of you having full control over every aspect of that. Because like you say, there's nothing necessarily stopping you from applying that software to all other pieces of hardware, but that means that you have to test for a massive variety of pieces of hardware to make sure that all of those interstitial layers actually work the way that you're hoping them to. Where if you're working with the one bit of hardware you've had forever, then you know exactly what it is. And so I absolutely see the value in sticking to your own stack kind of through and through, as it were. Yeah.
I think it will become easier now that we're moving into more Linux-based systems. Microcontrollers in particular, they all operate so differently. Like you have to know the size of the flash page before you figure out how you're going to do an over-the-air software update, because like the way that you delete code, or you delete data from flash depends on a lot of details about that microcontroller, and if you don't pay attention to those details, you can do bad things. As a one very specific example, right? Now we're into Linux-based devices. It is more true that we can just rely on Linux to make things work under the hood, with all the caveats that anybody who's worked in these systems knows, which is like, well, at least that's more true in these systems than it is in microcontrollers, but like it's not perfectly true. And so I do think that there is more of a path to say we can do this more broadly for Linux-based systems rather than just Tachyon. And I'm sure that will be something we'll keep looking at and debating and figuring out, like how do we make this something that everybody can use. But in the meantime, really focusing on making Tachyon a great product and experience that works out of the box and is seamless in a way that we're, I think, uniquely good at delivering.
Absolutely, yeah. And this is going to be a bit of a curveball question, actually, but I think it's always a fun one to ask people, because I've spoke to a lot of folks who do a lot of different things, whether they're people who make a product or are slightly more kind of free agents who work with a wide variety of things but have a lot of experience. But outside of the things that you're actually working on now, what are the last couple of things that you've seen in this space that made you kind of go, oh wow, that's neat? I think just to preface this, I want to make it clear, it doesn't have to necessarily be a piece of hardware. One of the things that kind of blew my mind recently was a company called Circle, I think, and they have made an entirely safe Rust software API for working in the automotive industry.
Yeah.
And I like the Rust programming language, and I think, oh, that's now Rust is just in cars. That kind of blew my mind when I saw it. So you can be quite esoteric with it, but what's the last thing you saw that made you go, oh, whoa, that's cool?
So I think that one of the things that I'm often thinking about is sort of ubiquitous connectivity, right? So like, and what does that phrase mean? Another like jargony thing that, buzzword. I think of ubiquitous connectivity is like the idea that you can have a thing and you can just like plug it in and it will just connect anywhere in the world, no matter what it is. And that's a really valuable place to get to, because there's a lot of applications that require it, right? Like it sort of has to be like, I don't know where this thing's going to go. A lot of our customers they're not in control of where the product gets deployed. And so they put in radios and they just like really hope that wherever it gets put has a cellular network or a Wi-Fi network that it can attach to. And if it doesn't, then like not much they can do. So we started working on, last year we did multi-radio and we added satellite and LoRaWAN. And so we can have like a cellular Wi-Fi satellite and LoRaWAN combined product. It's called Muon. And the pitch is the sort of ubiquitous connectivity pitch by combining radios. But in doing so, we finally got to like poke at both satellite and LoRaWAN in a way that we really hadn't prior, because we've been doing cellular and Wi-Fi stuff. And I think in both cases, like there's really interesting stuff happening right now. So our satellite partner is a company called Skylo. And we've looked at satellite forever. And like, it's been like, is it ready? Does it not suck enough that we think it's worth spending resources on like adding, right? I've been like waiting for somebody to get it right. And we kept bumping our heads against it and being like, no, not ready. And then the fact that basically Apple made something really cool with its like SOS feature in the iPhone that was proprietary to Apple, but the existence of it then created like a standards body thing where like the 3GPP, the group that does cellular stuff, like made a standard to do this broadly. That's part of the I don't remember the numbers on all this stuff, the standards, the crazy standard stuff. They standardized a approach to do cellular, what they call NTN, non-terrestrial networks, that basically they repurposed narrowband IoT, which hasn't really been as successful globally. It's very successful in China, but not elsewhere. They repurposed it and like reused the protocol running over a satellite network. And Skylo has been one of the companies really at the lead of then taking all of that and making it usable for folks. And so that's one where I think that that's really cool. And it's now possible to do things that really weren't possible before. And you see it in like yesterday, Google announced the Pixel 9 phone series and they announced SOS, and that's powered by Skylo. And so like you see it in the consumer smartphones perspective, but I'm like so excited that is usable now and that we can make it possible for people to use it in IoT context. I think in LoRaWAN, I mean, I've watched that world closely, the like LPWAN space for a while, just kind of like hoping that like the pieces would come together, because we can't do anything in those areas until like somebody else does a thing. And so you watch Sigfox, all these like prior generations were just like waiting. And then LoRa, I think, has really, aside from just being a really good piece of technology from Semtech, like the like puzzle pieces came together. And so in a way that like finally there's a very healthy and vibrant ecosystem around it. One of the things in there that I think is really cool is Helium, which is the crypto-based network that when Helium launched in 2015 or whatever, like, I mean, it's kind of like beginning of crypto, like Web3 hype. And like my take was like, no, just not, there is, you're telling me
there's no way this will work. Yeah.
A bunch of people are going to like put up radios to mine tokens and like we're going to have a peer-to-peer distributed network with no ownership and then it's going to work. Like I do not believe that that will ever be possible. And then the token value went through the roof and a lot of people can make a lot of money deploying the radios. And so they put them everywhere and the token value has collapsed, but the network is still there, right? Like it takes effort to put up a radio. It also takes effort to take down a radio. And so if you've already put it up, you're probably just going to leave it there. And so you now have this like incredibly high quality, vibrant network that has 300,000 hotspots deployed all over the world. And like, 85% coverage of North America. And you're like, geez, like, or the US at least. And so you look at it, you're like, well, goddamn, like it worked. Now, there's another challenge of like getting devices deployed on the network. And it's not, I think that we're still looking at ways to sort of make it easier to use and to create some redundancy with other networks. So you have a little bit of a quality of service guarantee, but just like it worked, it happened. I think that's so cool.
It's insane, isn't it? Yeah. Like LoRaWAN is next to, stuff, right? Yeah. Like for me, LoRaWAN is next to RISC-V in terms of like, this is really like things like this can still happen now. Because this is like old internet talk. This is like the stuff that happened in the past where it was like when everything was just beautiful and just worked and there was less people doing it and people did things for the love of it. But the idea that we're getting things like that a democratized made network just sprang up completely blows my mind. Yeah, no, I definitely agree with you. LoRaWAN is one of the technologies that I wish I had more time to delve into it. But I do have some LoRaWAN gear that I've been wanting to sort of just put together something just to be a part of it, really. Right. Because it's such a fascinating thing.
It's amazing, like when ecosystems develop around a thing, and I do think ecosystems end up being a lot of how technologies end up being popularized, right? Like there's a gazillion programming languages out there. Why do people know Python and JavaScript over other programming languages? Like, is it because they are fundamentally better than other programming languages? No, there are people out there who are using the like really obscure programming languages that will fight they will like, here's why we should be using Clojure, and here's why we should be, like those people are out there and they will fight hard for those things. But like some combination of like, the right qualities and the right tooling and the right leadership and the right like ecosystem organically developing around it. Maybe somebody did that on purpose. Maybe it just happened. Like watching how those things become the thing everybody uses, right? Is it's like a sociology experiment, right? And it's fascinating to see those things come together. To your point, like it's like the good old days of the internet. Like standards just came to be, right? And came to be accepted and came to be used, and all the bits and pieces kind of show up organically. It's awesome.
Yeah, it really is. Yeah, it's interesting as well that you sort of mentioned those two things specifically, because the way that people are sort of learning about connectivity is changing. Because and I'm assuming you as well were sort of that bridge generation where we grew up, and in the beginning there wasn't even really phones, like mobile phones, for when we were very young, and then there suddenly were, but they were kind of clunky things, all working with SMS, and there wasn't really any GPS involved. And then slowly we all have these things where young people today are walking around with cellular connected devices in their pocket that can stream things that my modem couldn't when I was a child. You know what I mean?
Right. Yeah.
And so with that comes a bunch of people who are learning the ins and outs of this and reverse engineering everything. And I don't know if you've seen this, but there's a real effort going on right now, for example, to open source the ESP32's Mac so that you can have a fully open source stack for the tech of that. And that's another thing that I just find sort of amazing, is that with all of these technologies, you have some stuff which is just out of our hands. You need a provider for satellite because we don't have satellites,
Right. We're not just going to like put one on a little model rocket and like shoot it up and be like, I've got one satellite. out there.
Precisely, yeah. But there's a whole bunch of people who are still keeping that idea alive of saying like this technology is so wonderful that people are starting to really make it their own and make wonderful things with it. And again, it kind of leads back to this idea of an approach of saying that you can do almost anything yourself these days. Which is why it's such a wonderful thing when people come together and say, so you can do this, we're going to do this, we're going to do all the hard work to reverse engineer it. For people who don't want to do that, there are ways of doing this out of the box without having to do every single step yourself that just work. And it shows that there isn't an us versus them mentality. It didn't do it this way, like because this is bad and that's good, or this is bad and this is good. It just shows that regardless of your entry point into it, this technology is really becoming democratized to pretty much anybody, which is a wonderful thing. Because I could certainly have never become the person that I am and have the career I have if it wasn't for the work of others documenting very carefully how they've, everything from blinking your first Arduino LED through to the people who very patiently helped me on forums when I tried to learn AVR assembly. And asking incredibly basic questions that I could have probably looked at myself. But at the end of the day, you don't have to do all that because, as I mentioned, you can, with the Arduino metaphor, you can just open up the Arduino IDE and learn how to make an LED blink by looking at example code and tweaking it.
Yeah.
And a few steps up the ladder of that is a full IoT system that is given to you as a service that you can just do your application thing at one end, and the rest will, as you say, just work. It's really, yeah. I really like the fact that this exists.
I think that I think about a lot of this. In some sense, you could categorize Particle in a bunch of different ways. One of the ways you can categorize is by calling us a developer tool, right? That like fundamentally, we live in the world of our users are developers or engineers, depending, or makers or thinkers or hobbyists, right? Like self-identify however you want, right? Like I think of all those people as being the same thing. Those are our users, right? And developer tools, the goal is to provide, productivity and enjoyment for the person who's doing the work, right? And who has a job to do and has an outcome that they're trying to deliver on, that can come up in a bunch of different forms. And abstraction, right? The fundamental principle of abstraction is that, like, as a developer tool, your job is to abstract, is to take away some complexity and hide it, right? But you have to hide it very carefully because somebody might want to debug it and they might want to look inside. And so and I think that that's where there end up being all these realities of abstraction that are like, the more you abstract, the more you potentially distance somebody from understanding the underlying technology. You create trust issues of like, do I trust that this layer is secure, reliable, right? Like, and also, like, if you are learning, right? If you are trying to actually learn how the technology works, abstraction is bad. Like you want to write assembly code because you're trying to learn how the computer works, right? And so, and I think this is where having abstraction, but also letting people like dig in and creating pathways to allow for self-education, allow for building trust, right? Like is the sort of like the right way to do it. But the practical nature of delivering developer tools that people actually want to use that are abstracted enough that they create productivity, but also transparent enough that they don't make people mad because they're hiding things, or creating lock-in or things like that. Like it is hard, right? And
that's a thin line.
And but it's also, it's fun, right? Like it's such an interesting set of problems to go try and tackle. And I think it's something we do, but like all these standards bodies, right, trying to do the same thing, just at a funky corporate level, right? And like open source communities and projects, and how did Semtech get everybody to use LoRaWAN? Like I would love to read a book one day for like what, aside from making a good piece of radio, there's like some story that exists somewhere where like 3 people went around and figured out like how to get everybody to play nice in this ecosystem. And like, I want to read that book. Like,
me too. I wish there was more books like that. The story behind these things is fascinating to me, and I'd love that. I'd love it if that was a thing. Hell, maybe I have to write it.
So I don't think it'll write itself. So that's the story's out there somewhere.
Lovely.
Cool.
I understand. I can see that. Unfortunately, we're both absolutely running out of time. So I would love to pick up this conversation at another point, at some point, if you are up for it.
Yeah, absolutely.
But for now, thank you so much for both of the kind of small interviews that we've had here. And I don't know whether they'll both go out as one big thing later. Certainly the first half of it will end up in the next Electromaker show. But Zach, thank you so much for your time today. I look forward to chatting to you again.
Likewise. Thanks, Ian.
Cheers, pal. Take care.